I'm going to be talking about graphing inequalities. Now we've already seen how to graph different kinds of functions, but what about graphing an inequality? Let's start with linear inequalities. Say that we start with a linear equation, y is equal to 3x minus 1. Instead of an equal sign here, we could put a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. Let's try two different ones. Say y is less than 3x minus 1, and y is greater than or equal to 3x minus 1, to see how to do this. The first step to graphing an inequality is to identify the boundary. The bounding line for both of these inequalities is going to be y is equal to 3x minus 1. Let's start on the right side by graphing the bounding line. Since the slope is 3 and the y-intercept is minus 1, it should look something like this. Now this line has all the points where y is equal to 3x minus 1, but in this inequality, y greater than or equal to 3x minus 1, we want to identify each value of y that lies above this line, or on it. This is because any value of y which is larger than 3x minus 1 will be a point that lies directly above the point where y is equal to 3x minus 1 for some value of x. So to identify this region above the line, we can simply shade it in, like this. Now let's do y less than 3x minus 1. For this inequality, we want to identify the points that lie below the line. However, we also want to exclude the line itself, since it's a strictly less than sign instead of less than or equal to. To do this, we draw the bounding line as a dashed line, like this. And now we can shade in the region below, like this. In general, if you're unsure whether to shade the region below or above the line, simply choose a point that's above the line, then test to see if the inequality holds. If it does, shade in the region above, and if it doesn't, shade in the region below. For example, in the inequality y greater than or equal to 3x minus 1, we could choose the origin here, which is above the line. If we plug in the x and y values for that, we get 0 greater than or equal to 3 times 0 minus 1, which is 0 greater than or equal to minus 1. Since this is true, we shade in the region above. Next, let's talk about graphing absolute value inequalities. Suppose we were given the inequality y is less than absolute value of x plus 3. The first step to graphing an inequality like this is to identify the bounding line. Or actually, in this case, it'll be a curve that isn't a line. Here, we have y is equal to absolute value of x plus 3. In general, to find the boundary, we can simply replace the less than sign, or whatever else is there, by an equal sign. Now first, let's graph this to see what it looks like. These are our x and y axes. Then, absolute value of x plus 3 will look like this, where the bottom point is at 3. This is because the graph is going to be exactly the same as absolute value of x, but shifted up by 3, since it's absolute value of x plus 3. Now that we've identified the boundary, we can graph the inequality. If these are our axes, then we want to draw the boundary, but it should be a dashed line, like this, since we have a strictly less than sign instead of less than or equal to. Again, this point right here should be at y equals 3. Finally, if we test a point that's above this boundary, say x is equal to 0 and y is equal to 10, 0, 10, that should be somewhere up here, then our inequality says that 10 is less than absolute value of 0 plus 3, which is just 0 plus 3, which equals 3. Since 10 is not less than 3, this means we need to shade the lower region. So our inequality will look like this.